Today we are doing section 3.5, derivatives of trigonometric functions. Let's look at example 1. Graph f of x equals cosine x minus 1 all over x using your calculator, and determine the limit of f of x as x approaches 0. So go ahead, take a moment, and plug that into your calculator. Let's see if you can find out what the limit as x approaches 0 is. Once you get it in your calculator, your graph should have looked like this. And when we look at the limit as x approaches 0, it is 0. So the limit as x approaches 0 of cosine x minus 1 all over x is 0. Let's look at example 2. Find the derivative of y equals sine x using the derivative definition. So we need to use our limit definition. So I'm going to have the limit as h approaches 0 of sine of x plus h minus sine x all over h. Then using your sum identity for sine, the sine of x plus h becomes the sine of x cosine h plus sine h cosine x. So this would be the limit as h approaches 0 of the sine of x times cosine h plus cosine x times sine of h. And then don't forget your minus sine x. And this is all over h. Then noticing I have sine x in two terms, I can factor that sine x out. So I have the limit as h approaches 0, factor that sine x out, and I would have cosine h minus 1, and then I would have plus my cosine x sine h all over h. Notice in this, I have two separate terms here, both over h. I can separate those into one limit as well. So I could rewrite this as the limit as h approaches 0 of sine times cosine h minus 1 all over h plus cosine x sine h all over h. Looking even further, I can take these two limits separately. I can take the limit as sine approaches 0, and I forgot my x right there, as sine approaches 0, and then this. And same here, I can take cosine x separate from sine h over h, as long as it's multiplied. So I can have the limit as h approaches 0 of just sine x times the limit as h approaches 0 of cosine h minus 1 all over h. Then I have my plus, the limit as h approaches 0 of cosine x times the limit as h approaches 0 of sine h all over h. We know the limit as h approaches 0 of sine x is just sine x. The limit as h approaches 0 of cosine h minus 1 over h from our first example we know is 0. Then I have plus. The limit as h approaches 0 of cosine x is cosine x. And we know from previous lessons that the limit as h approaches 0 of sine h over h is 1. So therefore, this would just equal 0 plus cosine x, or just cosine x. So my derivative with respect to x of sine x is cosine x. So using your calculator, find the derivative of y equals cosine x. Don't forget it has to be in radian mode. So try to do that on your own for a moment. What I did is I graphed the derivative of it, and I looked at this graph. And I looked and I was like, what does this look like? Well, if you look at it and you actually have these points here, and you have where it goes through the zeros, and it's sinusoidal, you should notice that this is the negative sine curve. So the derivative with respect to x of cosine x equals negative sine x. We're not going to derive each trig one like we did with sine x, but you could do that with each of them. So we have established that the derivative of cosine x is negative sine x, and the derivative of sine x is cosine x. Let's look at this example. Find the derivative of sine x all over cosine x minus 2. So we need to find the derivative of this with respect to x. Okay, so that would equal, we would have to use our quotient rule because that is a quotient. So it would be the denominator, which is cosine x minus 2, times the derivative of the numerator, which is the derivative of sine x is cosine x, minus the numerator, which is sine x, times the derivative of the denominator, and the derivative of cosine x is negative sine x. The derivative of minus 2 is 0, so it would just be times negative sine x, all over cosine x minus 2 all squared. So let's go ahead and simplify this. Let's distribute our cosine x and our sine x's. So I would have cosine squared x minus 2 cosine x plus sine squared x all over, and usually with our denominators we don't distribute just in case anything can factor. So it'd be all over cosine x minus 2 squared. And then I notice that I have a trig identity, cosine squared x plus sine squared x. That equals 1. So I would have 1 minus 2 cosine x all over cosine x minus 2 all squared. And that is your completely simplified form. Now, if this was a free response problem, you do not have to simplify it. This would be a perfectly good answer for a free response. So for a free response question, you can stop here. You don't have to simplify it. But if it's multiple choice, you have to go through and simplify all the way through for multiple choice. Let's look at example 5. Find the equation of the tangent to y equals x cosine x at x equals 1. So we have y equals x cosine x. We need to find the y coordinate at x equals 1. So let's start with there. Since we're going to have to find the equation, we need a point. So y would be 1 cosine 1, or just 1 cosine 1. So I have an ordered pair of x equals 1 and y equals 1 cosine 1, or just cosine 1. So I have my x and y coordinate. The next thing we need to do is we need to find the derivative, because the derivative gives you the slope of the tangent line. So we need to find dy dx. And since this is a product, we will have to use the product rule. So it would be the first part of the product, or the first factor, which is x, times the derivative of cosine x, which is negative sine x, plus cosine x times 1, because it's the second part of the product, times the derivative of x, which is 1. This would just be negative x sine x plus cosine x. So this is the slope of the tangent line at any given point, but we need to find it at specifically x equals 1. So I need to find my derivative at x equals 1. So I would go ahead and plug in negative 1 sine 1 plus cosine 1. So that would just be negative sine 1 cosine 1. So plus cosine 1. So it's not pretty, but that would be your slope. So now using point slope form, we go ahead and we plug in. We'd have y minus cosine 1 equals negative sine 1 plus cosine 1 times x minus 1. And that would be the equation of your tangent line. Unless they tell you to put it in any other form, leave it like that. You do not need to distribute. The only time you need to distribute is when they specify to distribute. We're not going to derive the other trig derivatives, but if you wanted to, you could use the limit formula for derivatives. So we already found sine to be cosine, the derivative of cosine to be negative sine. The derivative of tangent x is secant squared x. The derivative of cosecant x is negative cosecant x cotangent x. The derivative of secant x is secant x tangent x. And the derivative of cotangent x is negative cosecant squared x.